Okay, so this assignment is all to do with Newton's second law. Okay, there's really nothing else on here except for that. Some of the questions will involve friction, okay, including coefficient of friction, which we talked about last week. Some of these are ridiculously easy, okay, and some of them are going to require a lot of thought, okay. Only a very few of them actually require a great deal of math, okay. So just kind of be on the lookout for those. Look especially at point values. Like question number 1 is out of 2 marks. Do you suppose there's a lot to do? There really isn't. On a 2-mark question, it's like givens and an answer, basically. Like, okay, so we don't require a ton there. Okay, but things that you'll want to keep an eye out for will be significant digits. You can really get nickel and dimed with that if you're not careful. Okay, because every time you have the wrong number of significant digits, you're going to lose a mark on that question. That would really suck for like question number 1, which is 50% of the marks. Okay, so make sure that you are keeping an eye on your significant digits. On a similar vein, many of these questions have answers that require vectors, and it would be unfortunate to miss those and lose a mark because you didn't write along the x-axis or north or whatever it happens to be. Okay? All right, so for question number 1, you got a crazed 4-year-old on a tricycle and they hit Cam, and Cam's acceleration, or sorry, the kid's acceleration is 1.5 meters per second squared, and his mass is 32 kilograms. Okay, what is the force exerted by Cam, on Cam, sorry, by the angry 4-year-old? Okay, so not a terribly difficult question. You're looking for acceleration here, and you have 2 givens you can usually use to get that. All right, just keep in mind that you might be solving for something that's a vector quantity. Okay, and so that could be something that is important, even if it's as simple as positive or negative. Okay. Number 2, kind of along the same vein, you're given some acceleration information and you are asked to calculate the net force that is acting on the vehicle, okay, in this case a Porsche. Okay, you know the mass, and for some reason there's a space in between magnitude, so that's supposed to be one word, magnitude, not magnitude. Magnitude, okay, and direction for that one. For number 3, okay, force vector, 720 newtons, points 38 degrees north of east. Don't overthink that one. You are just looking for the vector components. Okay, you've done that before on the other vector assignment. Okay, you're just looking for the vector components on that one. Now, number 4 is a 3-part question. Okay. So you have 3 different situations, and I want the acceleration in each. Okay, so this is kind of like, this is part A, this is part B, and this is part C. Right, so basically each one is out of 3 marks. Okay, and what we're looking for here is for you to calculate the acceleration. What I have given you are the free body diagrams. All right, so you don't have to draw those, but there might be another diagram worth drawing that will help you get where you need to go for this. Okay? So it's a 3-part question: acceleration in A, acceleration in B, acceleration in C. It's the same forces, all I'm doing is changing the directions they point. Okay, so basically the 40 Newton force always points along the x-axis. Okay, because it asks relative to the x-axis, which means no compass directions for number 4. Okay, all that changes is where the 60 is pointing. So in this one, it's pointing at 60, or sorry, straight up. Okay, so straight along the y-axis. This one here, this angle is 45 degrees above the x-axis. Okay, and then the other one, they both point along the x-axis, positive x-axis. Okay. Okay, number 5 is a vector question, and really a vector question only, but you kind of have to work backwards. All right, so in this one here we have a sphere that's acted upon by 2 forces. One of those forces is 113 newtons, along the positive x-axis and a second unknown force. Okay? We're looking for the magnitude and direction of the second force such that the sphere accelerates at 3.96 meters per second squared, 21 degrees above the x-axis. Okay? So you have one of the two forces that are causing this acceleration here. Okay? Since you know that acceleration and the mass of the sphere, there's something there you can calculate that will help you find the missing force. Okay? But I will tell you this about the missing force. It is angled. It does not point straight up. This is not a perpendicular vector question. Okay? You have one vector that is along the x-axis. The unknown vector is angled. And you will have to find it. Okay? Number 6. This one people overthink all the time. So while I'm explaining it, maybe write something down that helps you understand it a little better. This spacecraft has 4 engines. The engines are all the same. They can all exert this much force. And there's no throttle. They're either on or off. If they're on, they're exerting that much force. Okay? This spacecraft is initially moving this way at 2,170 meters per second. I don't want to go that way anymore. I want to wind up going this way at 2 times that speed. Okay? So that means this question consists of 2 parts. Stopping that and doing the other. Okay? They are not done together. One is done first, the other is done afterwards. You need to calculate which engines need to be fired and for how long. So it's also an acceleration question. It's a forces question, but there's also an acceleration part to it. Okay? Initially, we're going 2,170 meters per second. We want to stop, and then we want to go this way at twice, and have our final velocity be twice that number. Okay? The engines can only fire at that rate, 68,000 newtons. Okay? So you got to figure out how long and which engines need to be fired. Okay? So basically your final answer will be engine this many seconds. Engine this many seconds. Okay? All right, 7 and 8 are street lamp questions or sign questions, static condition questions. Okay, so hanging signs. All right, one of them, okay, it's the wires are in a V. Okay, for question 7, the wires are in a V. For question 8, they're angled like this. We have done example questions just like these two. So if you've always been writing down the examples in class, you have examples of these 2 questions. Okay? All right, and again, look at the point values here. Like number 8, there's not a lot of math. A fair amount of thinking, but not as much math. Okay, question 9. Okay, so we did a question like this on Friday. Okay, it's a Newton's second law, vectors, and forces question. That's why it's worth 6 marks. Okay, there's a fair amount of calculating to be done there. Okay, you are looking for the angle the handle is making with the horizontal and the normal force exerted on the suitcase in this situation. The key parts of this is that the suitcase is moving at a constant speed, okay, and it is also moving horizontally. Okay, you might want to make a note of that because it doesn't actually say anywhere in the question, okay, but the suitcase moves horizontally. So it's moving along the ground. Okay? It's not pulled that direction, but that's the way it's going. Okay? It's pulled at an angle, very much like the question we did on Friday. Okay? 10 and 11 are your inclined plane questions. Treat them as such. Watch out for this trick. Okay, in the interest of having you get as much of this done in class as possible, I will shut up and you will get to work. Okay, you have all of class today to work on it, provided we make good use of our time. Other note, I have decided on the exam date for this unit, and it will be November 15th. That's a ways away yet, 2.5 weeks. Okay, but know that that's going to be the day.